Hi everybody, today we are going to take a look at some questions about the normal distribution. We're going to look at some problems that ask you to find a z-score given an area or find an area given a z-score. Before we get into those problems though, I want to make sure you know about the resources we have for this stuff at the Student Success Commons. So let's go there. If you go to Math, Statistics, first of all, we have all of the formulas, and we have the table, the z table right here. But we also have, what are we in, chapter 5? Chapter 5. So we have this PDF here, all about the standard normal distribution. Actually, I'm going to start here before we even get into the problems. So, and you can download this and print this out for your own notes for yourself. But this is going to help get you familiar with the distribution, as well as it shows some examples that we're going to go through today. We'll go through some different ones, but you'll have some extra examples in here. So finding an area, I think, and then finding an area to the left of a z-score, to the right of a z-score, between two z-scores. But it also just gives you an idea of what the standard normal distribution is and a slightly easy way to think of it. So I like to look at it as a number line. It goes from either -3 to +3 or -4 to +4 in our problems. And the total space underneath this blue curve is 100%, or 1. That's how much area there is in there. So that means if you cut it down the middle, to the left of the middle would be half of it, and then to the right would be the other half. We just need to make sure we keep that in mind when we're working on these problems. So that the mean of the normal distribution is 0. No, that's not it. Where is it? There it is right there. It's bell-shaped. If you cut it in half, it's mirrored on either side. And where did I put the part where it says? There we go. The total area under the curve is equal to 1 or 100%. So that means 0.5 or 50% is below or less than the mean. So that's on the left. Oh, yeah, that's left. And the other half is above, greater than the mean, which is on the right. And also, just so you know, the terms area and probability are pretty much interchangeable in problems regarding the normal distribution. So if they say the area is 0.3418, that's the same as saying the probability is 34.18%. So let's just keep these things in mind. And again, you can go to the SSC's website and you can download that for yourself. And actually, we have a whole bunch of other resources that we're going to go through. But let's get into some problems first. Alright, so let's look at some problems where we are given an area and we have to find the z-score that matches it. So use the table of cumulative areas under the normal curve to find the z-score that corresponds to the given cumulative area. If the area is not in the table, use the entry closest to the area. If the area is exactly halfway between two entries, use the z-score halfway between the corresponding z-scores. So we have these 5 different areas, and we are going to try and find which z-score matches it. So let me draw this first one. The first area is 0.0612. I'm going to actually draw what that would look like, more or less. This is not going to be the scale, and it's probably going to look like a 4-year-old did it. But when I was first learning this stuff, oh yeah, that's definitely a 4-year-old drawing. It helped me a lot to visualize it, because I was really confused about the z-scores when I started. But then when I realized you could visualize it, it helped me. So here's the normal distribution. Mine's kind of flat. Sorry. Here's smack dab in the middle. This is the z-score of 0. 0 is always in the middle for the z-score. And we know that 50% or 0.5 of the area is over here, and another 0.5. 4-year-old handwriting too. Another 0.5 is over here, and they've given us an area of less than 0.5. Less than 0.5 of 0.0612. That's really pretty small. So that's about 6%, just over 6%. So if this whole thing here is 50%, 6% would be like, way down here, maybe? So it's not very much. And remember, I said earlier, you can kind of look at this bottom line here as a number line. So we've got -1, we've got +1, 2, -2, 3, -3. So from the drawing that I've just done, and I know that I'm working with less than 50% here, I've only about 6%, I'm thinking my z-score is going to be in the negative somewhere. So let's go back to the SFC's website here. Let's open up the table that we need. All right, so here's the table for standard normal distribution. And I think my z-score is going to be in the negatives here, so it's the first page. And what I'm going to do is I'm going to look in what's called the field. So all of these numbers in here, not the numbers on the edges. You only look at the numbers on the edges if you have the z-score or if you've found the z-score. So we're going to look in the field and we're going to see if we can find the number we were given. We were given 0.0612. I have the memory of a dying goldfish. I'm going to have to go back to that, I'm sure, but 0.0612. So let's see if we can find that in the field. 0.06 is where I'll start looking. So you can see this is 0. Well, there's no 0 in the front, but it's 0.02. I'm looking for 0.06 is where mine starts. So, okay, here's 0.0606, and here's 0.0618. Ours, oops, wrong tab. Ours is 0.0612. 0.0612. So it's not here. It's in between these two. Let's figure out which of these is closer to 0.0612. Which one is closer? And so to do that, I'm just going to grab a calculator, and I'm going to subtract. I'm going to take 0.0612, the one I am looking for specifically, and I'll just not multiply. I'll subtract each of these, and whichever one has a smaller difference is the one I'm going to go with. So first I'll subtract the 0.0606. Oh my, that's scientific notation. Let me grab a calculator that doesn't use scientific notation because I'm too tired to work with that. Let's try this again. Okay, 0.0612. That's the one we're looking for. And the first one we found that was close to it was 0.0606. So the difference is really, really small, 0.0006. Okay, remember that number. Sure as heck no, I'm not gonna. But remember that number. Let's now compare the other one, the 0.0618. So again, I will start with the number I was specifically looking for, 0.0612. And I'll subtract the other number that I found that was close to it in the field, 0.0618. Now don't worry about the negatives here. For this process, we're not looking at a negative or positive, we're just looking at the number itself, and it's exactly the same as the last one. So if we look back at our instructions, it did say if the area is halfway between two entries, use the z-score halfway between the corresponding z-scores. So that's the situation we have here. So let's look at what these two z-scores would be. So for this fella, the first one, 0.606, the z-score is, if I follow it back, negative 1.5. That's the row it's in. And the column that it's in is 0.05. So the z-score for this one is negative 1.55. And the z-score for the other one is negative 1.54. Grab my calculator again. So I have these two z-scores. Actually, I don't want this one anymore. Sorry. I have negative 1.55. That was, if you can kind of follow the column along. So the column is here. I'm sorry, the row is here, negative 1.5, and then the column is 0.05. So if you slap those two together, you get negative 1.55. Ignore the initial 0. That has been taken up with a 5. There it is, the 5. So negative 1.55. And then the other one I have is negative 1.54. Just write these down so I don't forget. And it says that if the area is in between two entries, use the z-score in between these two z-scores. And essentially, to do that, if ever you need to find the z-score in between two z-scores that are right next to each other, you take the lower one and you add a 5 at the end of it. So our z-score is going to be negative 1.545. So z-score equals negative 1.545. That's right in between the two z-scores we found on the table. And my picture here was really bad, but we did know it was going to be a negative because the area was less than half, less than 0.5. So we knew it was going to be negative, and we found it. And since this is probably pretty new to you, and you were probably just as well, you might be just as confused as I was. Boy, I hated this section where I started it. There is an online calculator you can use to check to see if you've done it right. We've got two of them here. Find z-score given an area is what we're doing right now, so you can check it. Ignore this top box. Make sure that's empty. And we're going to use the second box here. Probability that x is less than z. And I've picked the less than one because whenever you're given an area, unless they specify it's greater than or one of these other ones, you always go with the less than one. That's just how this table is designed. It's designed to work with cumulative areas from left to right. So let's see, our area is 0.0612, and sometimes you'll see the 0 point, or you won't see it. It doesn't really matter. It's the same. Let's calculate this, and oh, look at that! Look at the z-score it gave me. Oh, stop it. Negative 1.545, and I'm pretty sure that's what we decided on. So just know that there is this calculator online. It's linked on the SSU's website that you can use to double check your answers. And look, it drew this picture right here for us. When the area is the x is less than z, you have an area of 0.0612, and it had it shaded over here on the left, just like, well, it's way better than mine, but just like we had done here. And it's a great way to check as you're getting used to using the table and checking things out. So let's keep going. We have a couple more problems in this section. So the next area is 0.5. So let's go back to the table. Table. And again, look in the field because that's the areas. You have an area of 0.5 or 0.5. You're going to scroll around until you see it, and I see it, 0.5. There's a bunch of extra zeros at the end, but zeros after a decimal don't matter. So the z-score they've given me is negative 0.0, and then the column is 0. So essentially, they've just given me 0, which makes sense since we know that half, or 0.5, of the area is to the left of 0. So if you have half, or 0.5, of the area, your z-score is going to have to be 0. And you can still check that if you're not, you can still use the website to check that. Although I've never checked it with 0 because 0 is one of those ones where it's always, yeah, less than 0. Anyway, 0 is one of the ones where you're always going to have half on the left of it, half that's less than it. All right, let's move on to the next one. So this one, we have an area of 0.998. Let's go to the table and see if we can find that in the field anywhere. 0.998. Now that's go back to my really bad drawing here. 0.998. That's more than 0.5, right? Where's my pen? My pen's not working. All right, never mind. All right, 0.5. 0.998. If this is half and this is half, and the whole thing equals 1, 0.9 is pretty close to 1. So I'm thinking that we're going to be looking, grab a different color. We're going to be looking for a z-score that's way over here somewhere. because it needs to go almost all the way up until the area is full, because 0.998 is really close to 1, and the whole area under here is 1. So it's got to be pretty close to the end there. So I'm going to be looking at positive z-scores. I probably have this way off again. It's probably like over here. I don't know. But that's just to help visualize. All right, so let's look at the positive z-scores. Let's go to the next page of positive z-scores and see if you can find 0.998 or the closest one to it. And I can see a lot of 0.9s, 0.9, 0.9. Ooh, here's 0.9918, 0.9920. We're looking for 0.998, so I'm going to keep going. All right, here's 0.996. Here's 0.9979. Here's another 0.9979. Oh, there it is, 0.998. And again, an extra zero at the very end doesn't mean anything. It's the exact same. So we found the exact number we were looking for on the table. And if we look back at what row it's in row 2.8, and it's in column 0.8, so that means it's 2.88. That's the z-score. Nope, wrong tab. Z-score. Oh, the z-score is 2.88. And it is positive, just like we figured. And it was, oh, you know what? I actually did a pretty okay job. That's about where 2.88 would be-ish if a 4-year-old were drawing a number line. But like we said, because 0.9 is so darn close to 1, it's going to have to be further to the right of the bell curve. The smaller your area is, the further to the left you're going to be. Like our first one was 0.06, pretty small. We were way over here. When you get a bigger area, like 0.998, you're going to be further to the right. But like I said, you can always use this online calculator to double check it. And I'm going to do that. 0.8. Let's see if it gets me the same z-score of, was it 2.88? 2.7, 2.878. Did not expect that. 0.998, did I type it right? I did type it right. Right. Well, 2.8. I got the right tabs. 2.88, yeah. Usually z-scores are rounded to 2 decimal places, so if you do use this calculator to double check and it's off by a little bit like this, try rounding it to 2 decimal places and see if you get the same answer you found yourself. If we round 2.878 to 2 decimal places, we get 2.88. So this calculator is not infallible. That's why I'm showing you both methods. They work together to help you check yourself, check your work. So, but if we do round this one, we get 2.88, which is what we found in the table. So I'm pretty comfortable with that number. Let's go on to the next one. We have an area of 0.61. Just go back to my crappy drawing here. Remember that the middle line is where it marks off the 0.5. So if I have 0.6, 0.61, it's going to be a little higher than 0.5, which means it's going to have to be in the positive side of the z-score. So I'm going to look at the positive table again for z-scores. But this time I'm looking for 0.61, so I'm way too high with the 0.9s. All right, let's see. Here's 0.5, 0.5. Ooh, here's 0.6. Ooh, here's 0.6103. I didn't actually want the 03, but I don't have exactly 0.61. So it does say in the instructions, if the area is not in the table, use the entry closest to that area. And I think 0.61 is closest. There it is. 0.6103. That's pretty darn close. That'll work for us. So let's see. What row is it in? It's in row 0.2 and column 0.8. So together that gets you 0.28. Z-score, no, that's an X. Z-score is 0.28. Let's just look back at my little crappy chart thing. We said it was only going to be a little bit above 0, and 0.28 is only a little bit above 0. It's less than 1, which is what we kind of expected, and it's way less than this one over here. because it's only just barely past the 0.5. It's just 0.6, so it's right around there. I'm going to go back to that website and check it and see if I get the same thing. 0.6. I don't even remember. Just 6.1. Okay. 6.1. Calculate. And here's another example. It gave us a z-score that had 3 decimal places, which is a little off from what we found in the table. And again, ours, the one we found in the table wasn't exact. We just found the closest one. It had that little extra 0.03 on there. So, but if we round this to 2 decimal places, we get 0.28, which is exactly what we thought would be the right one anyway. So they check out. All right, on to our last one, 0.432. So this one, if I'm going to go back here, 0.4 is where it starts. So that's going to be less than 0.5, but not too much less. So it should be over here. It should be negative, but not crazy negative like -3. So it should be around there-ish somewhere. So let's go to the table and see if we can find it. So we're looking for 0.432. Back to the table. And I said it's going to be negative, so I'm going to look up the other page with the negatives on it. And I'm going to look for 0.432. Now these are all point zeros, 0.0, 0.0, 0.0. So 0.4 doesn't start until, here's 0.40. I'm looking for 0.43. Here's 0.42. 42. Oh, here we go. Here's one. 0.4325. So it's a little bit too high for what we were going for, because I didn't want that 5 on the end there. So let's check. Let's check these two here. Usually once you find one, and it's a little too high, you look at the number to its left and see if it's closer. Or if it goes the other way around, if you find a number that's a little too low, you look to the one to its right and you're going to compare them. So let's go back to the calculator and do that comparison we had to do for the first one. I think it was the first one. So the number we were actually looking for was 0.432. And we found, the first one we found was 0.4325. Pretty darn close. It's only off by, remember, ignore the negative for this part. It's only off by 0.0005. Not bad. But let's just double check to make sure this other one isn't closer. So we were looking for 0.432. Let's compare the other one, which is 0.4286. This one's off by 0.0034. Our last one was only off by 0.0005. So I think it's safe to go with this one. This one's going to be the closer one here. And so let's see, the row it's in is -0.1, and then the column is the 7, so it's -0.17. Write that down. Z-score equals -0.17. Yeah, 17. And that matches up with what we thought. We thought it would be negative because it was a little bit below 0.5, and we use 0.5 as kind of landmarks, and the 0 that goes with it. So we thought it would be negative, but not too much, not too far into the negatives. And we were pretty good. I could see -0.17 going right here. That's not bad. Let's go on to the calculator here and double check it. 0. All right, here's the z-score. They gave us it rounded to 3 decimal places, but let's round ours to just 2. That's usually what the instructions on your homework is probably going to be anyway for z-score. So if we round this to 2 decimal places, we get just -0.17, and wouldn't you know, that's what we had. So between the table, drawing it out, the calculator, you should hopefully be able to start getting some more practice and getting more comfortable finding z-scores that match given areas. Okay, let's flip the script now. So what we were doing before is we were given an area and we were asked to find the matching z-score. Let's say you're given a z-score and asked to find the area. So we're going to work on a few of these because these are pretty common. So here are some of our problems. Use the table of cumulative areas under the normal curve to find the area that corresponds to the given z-score or z-scores. If it is convenient, use technology to find the z-score. We're going to keep that in mind. So our first one, find the probability or the area for z-score less than 1.54. I'm going to go back to my drawing because it's really gonna it's the thing that really helped me out getting through this class. And I always start with 0 smack dab in the middle, and I make my little number line. And look at that, it looks like a 6-year-old now, not a 4-year-old. Alright, that should be good. Now let's see, it's blue. So these are the different z-scores. Sometimes I like to label this as the z-axis so I don't forget, these are z-scores. And there's an infinite number of z-scores in between them. So between 1 and 2, there's 1.5, and there's also 1.45, and there's 1.03, and all that. Those are our z-scores. The z-score we were given is 1.54, so let me first go mark that on the axis. So 1.54 is just a little tiny bit more than the 1.5, so just about halfway between 1 and 2. Now, if they ask me for less than, I will shade to the left. It points that way. If they ask me greater than, I will shade to the right. It points that way. You kind of look at these, the greater than, less than symbols. They point to which side of the graph should be shaded. And so, which way is mine pointing? Mine's pointing. It's like an arrow pointing to the left, so I'm going to shade to the left. Less than, left. They work together. So I'm looking for how much area is here. Alright, so let's look at the table. One thing that's really important to know about the table that we use is that it always gives you area to the left of a z-score. So if the problem that you're working on asks you for area to the left or less than, you're golden. You're just going to look up that z-score and boom, you're going to get the area. I made it sound really easy. Hopefully I can actually show you that it is that easy. So let's go to the table again. Table. All right, our z-score is 1.54. Now, this time we're not looking in the field first. We're going to be looking at the rows and columns to find the z-score we have. We have 1.5, so it's going to be somewhere in this row, and then 4, so it's in this column, and they overlap right here. 0.9839382. Just gotta copy that because now I'm gonna remember it. Now that number seems a little off to me, so I'm gonna go and check it. So it does say, if convenient, use technology to check to find the z-score. So if you go back to the SSC statistics page and you go down to online statistical calculators, chapter 5, there's this one here, normal distribution. This is a really great way to check your z-scores. Unless it's a word problem, leave mean and standard deviation alone. Below means less than. And our z-score, our less than, we said was 1.54. So I'm going to type 1.54, recalculate, and I got 0.9382. And look at that. Look at that. They made a much nicer drawing than mine, but I'm still going to give myself credit for that drawing. It's not as bad as it could have been. But the z-score that this calculator has given us, sorry, I got like 12 tabs open, 0.9382 is exactly what we had. So I felt a little funny about that one. I'm like, that seemed weird. But we do have an online calculator that lets us check it. So we're gonna keep that in mind as we go through these problems. But on to our next one, z-score of 0.72. Back to my drawing here. I wonder if it'll let me. Here we go. So 0.72, so it's positive, and it's not quite 1. A little there-ish, maybe. So that's where the line starts. Now, is it greater than or less than? Am I going to shade the right or the left? It is less than left. So I'm going to shade the left. And like I said, your table, the table that they give you to work with in this class, it gives you the area to the left. Your table might look a little bit different than mine. Sometimes, let me go back to the table. Sometimes these numbers on the top are in a different order. In my table, it goes from 0 to 9. Some tables, it goes from 9 to 0. Just keep a really, really close eye on that. If you've been following along with your table and you're like, oh my God, I'm not getting the same answers, what the heck? Look at that top column to see, because sometimes they do go reverse. And that's one of the reasons why we have these online calculators to let you check your work. Because if you're using different tables, although the information in them is the same, sometimes they're presented differently. So just keep that in mind. All right, back to our problem. We have 0.72 less than. Beautiful. So let's look for a z-score of 0.7. Here's 0.7. And then so this is the row it's going to be in. It's going to be in here somewhere. And then 2 is the other part of it. And so here's our z-score, our area, 0.7642. Paste that in there. So that basically is telling you if you throw a dart at the chart here. This is a really crude example. Let's say you throw a dart. Your chances of it landing in the blue part is what that area is. Your chances of it landing in that blue part right there, you got a 0.7642 chance, or about a 76% chance. And that kind of makes sense if you look at it visually, because a good deal of this is blue. So a 76% chance of hitting blue, yeah, that makes sense. The less blue there was, the smaller your chance would be. And the more blue, the higher your chance. So that's one way I was thinking of it too when I was learning it, as far as areas and probabilities and how they work together. Let's move on to the next one. So the next one, this one is the probability that z is greater than 1.54. Greater than 1.54. Let me draw roughly where that would be, 1.54. So like I said, did we do 1.54 already? We did. So that's right there-ish maybe. And this time it said greater than, so I have to shade this side. And this is different because the table does not give us areas to the right-hand side. It gives us areas on the left. So there are 2 ways you can go about this. And the easiest way is a little tricky to get the hang of. It's going to feel counterintuitive, but it is the easiest way I know of. So that's the way I'm going to show you here. If you remember that document I showed you at the very beginning of the video that kind of showed you an overview of normal distribution, it said that it's symmetrical. So that's going to come into play here. Our z-score is 1.54. Let's say we had a z-score of negative 1.54. Stay with me here. Now, if we wanted to, we could, and we were given, the probability that z is less than. Yeah, sure, that's less than. Probability z is less than negative 1.54. If we were given this one, like we were given this one, we would just go to the table, we would look up negative 1.54, and we would have the area. Boom, it'd be great. You can actually do that with positive z-scores. If you're given a greater than, a greater than problem instead of a less than, you can look up the opposite sign and you'll be good to go. So what I mean is we were given positive 1.54. I can look up negative 1.54 and it'll be the same area to the right of positive 1.54. So if I look up negative 1.54, negative 1.5, so it's this row here, and then the 4 puts it here. So I get an area of 0.0618, not a lot, but again, the blue part, there's not a lot shaded. Remember, the whole thing under here equals 1, so 0.6 isn't very much. Yeah. Wait, did I do that? All right. Yeah. 0.06. I said 0.6, didn't I? I don't know. Let's go here and check it. Now we're doing an above, a greater than. So let's check it. Let's see if I did that right. 1.54. That's our z-score. Recalculate. Boom. There it is. They have the shaded part. Not too shabby. I don't know why I keep saying boom. I gotta stop that. I need a better catchphrase or something. But there it is. There's our area, 0.0618, which is exactly what I found when I looked up the opposite sign in the table. So I know it's a little confusing to get, to get used to that. And if you're not comfortable doing that because you don't feel like you're ready to start swapping signs, use this calculator as a backup. The instructions did say if it's convenient, use technology, and it was much more convenient to do this. Just remember that above means greater than and below means less than. But this calculator is linked on our website. I was actually introduced to it a couple years ago by another tutor, and it's very, very helpful to check your work for this stuff. So I would bookmark it. I mean, I have bookmarked it, but if I were a student, I'd bookmark it. Okay, on to the next one. The next one says probability that z is greater than 0.02. Let me draw that. 0.02. That's really close to 0. It's way less than 1, so it's like maybe right there. And it said greater than. It was this symbol, which means it's the area on the right. And like we said in the last problem, the table does not give you areas to the right, it gives you areas to the left. So what you can do is you can look up the opposite sign and you can find the area. So if ours is 0.02, right? 0.02. I can look up negative 0.02. And whatever answer, whatever area I get is what I'm looking for. Because the table is symmetrical, area to the left of a negative is going to match area to the right of a positive, as long as the value is the same. 0.02, 0.02. So I'm going to look up negative 0.02. So I'm on the negative side. Here's negative 0.0, so it's going to be in this row, and then 2 is way over here, so it should be this right here. Should be 0.4920. That's how much space I should have shaded. And remember, 0 marks the halfway point. 0.5 and 0.5, one's on the left, one's on the right. So 0.49 is pretty darn close to 0.5, and the 0.02 is pretty close to 0. So the reason I'm bringing this up is because it can be helpful to visualize how much area is in a certain spot and how close they are to each other. 0.02 is super close to 0, and 0.49 is super close to 0.5. So I feel pretty comfortable about that. But you're probably still getting used to this, so go ahead and you can check it. Greater than is above. Type in the z-score, and like I said, leave the mean and standard deviation alone and just recalculate. There we go. We got 0.492, and you can see their graph is scale. It looks like it's at the 0, but it's actually just a tiny bit beyond the 0, kind of like what we did here with our 6-year-old drawing. And like I said earlier, a 0 at the very end, it won't make or break you. So I could ditch that 0 or keep it there. It doesn't really matter. It's the same thing either way. So, all right, so let's move on to the next one here. This one gives us 2 different z-scores, and it's essentially asking us to find the area in between these 2. I don't know if that's written properly, but I did grab these just from online. For this one, you can find the z-score, the area for each z-score, and then you can subtract those 2 areas. You might have seen that in, like if you are doing homework and you look at a similar problem, that's probably the method they use. For the purpose of this video and how long this video is getting, I'm actually not going to do that. I might make a separate video for that. For this, what I'm going to do is I'm going to use that online calculator. And we're looking for a z-score between negative 0.34 and 1.57. So between negative 0.34, 1.57. Let's recalculate. And it's going to give me my area. So I don't recommend that you only use this calculator. I definitely do suggest that you use the table and you practice it. It's kind of a pain in the butt. I do remember having to deal with that when I was a student, and I did not like it. I haven't decided if I like it now, but at least the more practice you get, the less you hate it. At least that's been my experience anyway. But the online calculator is definitely a good way to check your work as you're practicing, as you're getting used to things. And so I think I'll use that for the rest of these problems. This video is getting a little bit long and probably extremely boring and maybe even a little bit painful. So let's do this. Let's do it for the next one. So this one is what is the area lying between z-scores of 0 and 1? It's more or less how you could say it in just regular words. So between 0 and 1, those are nice. Recalculate. It drew it for me between 0 and 1. There's a shaded part, and there it is, 0.3413. That's actually, give a spoiler, but that's actually a pretty cool number. Comes up a few times. You might see it a little bit later on in statistics. All right, so this time, this one, problem 7 and 8 are looking for z-scores on opposite sides. So they're not between, it's outside. And I think that's one of the options on calculate outside. We're looking for outside. Let's see. One of them is less than, and one of them is greater than. That's what these two problems are looking for. So the first one is less than negative 0.78 and greater than 0.78. So I'm going to just plop those in. Negative 0.78, 0.78. And it gives me the total area less than negative 0.78 and greater than 0.78. If I found each area individually, added them together, and that's what they are. I'll try to make another video later about doing this part by hand because it's actually kind of cool. Not that you can necessarily trust when a math tutor says something is cool, but whatever. All right, so for our last one, it's another outside one. It's going to be less than negative 0.02. 0.02. You always do want to put the smaller one first. And then greater than 2.33. I'm guessing it's going to be kind of a small number. Oh, I was wrong. I guess I should pay attention. All right, so it found the area that was less than negative 0.02. It found the area greater than 2.33. Added together, the total area in these spaces is 0.5019. All right. So again, all of the things that I've showed you here, the table, the document, this calculator, they are all easily found if you go to the SSC's website. You go to math, statistics, all of our stuff is here. We have videos too, a couple of them. If I find some more videos on chapter 5, I will absolutely add them in there because I'm sure, more than just mine is going to be helpful. But here are the tables. We also have all the formulas. We have the symbols used. You can get used to those. We've got a couple of things you can download. If you have a TI-84 or if you use Excel, you can bypass the online calculator. You can skip using the table and you can find z-scores and areas that way. And so we have instructions for that. We have a couple of definitions. This we haven't gotten to yet. Don't worry about this. And then again, you can find the calculators here. And you can also reach out to a math tutor if you would like some support. During the summer, you can reach out to me. That's me. My email is kcole@ycc.edu. So if you have any questions, please just reach out. And if you have any requests for certain videos, you want to see certain concepts or questions explained, please just let me know. I'm happy to do it. If you have any requests for other resources that maybe aren't from me, if you're sick of listening to me, that's fine. I can absolutely scour the internet to find something that can help you out. So just let me know. I hope this video wasn't too painful, and I look forward to offering more math support in the future.